Then question number 31. In the figure shown, F1, F2 and F3 represent fixed vectors of three forces acting at the point O in x t plane, not it x t xy plane. F4 is vector representing the rotating force about the point O in the same xy plane. Which of the following best represent the direction of the resultant vector when vector F4 is 0, is at angle 0, 90 and 180. When F4 is 0, now there are three fixed forces, F1, F2, F3. We can consider there are two squares for F1, two squares for F2 and three squares for F3. When theta equals 0, theta means this angle. Theta equals 0, F4 is acting in this direction. F4 force is 1.5 square. Then we can cancel out 1.5 square from this one. The half square part is remaining. In upward direction there are two squares. We can cancel out this force and 1.5 part. Then we can cancel out two squares and two squares in downward direction. Now the resultant is in this direction. Answer 2, 3 or 5 should be correct. When theta equals 90, theta 90 means this force is acting in this direction. 2 plus 1.5, 3.5. Then in upward direction, there is a force representing half square. In this direction, again half square. Then resultant should be like this direction. In first one, resultant in this direction, second one this direction. Third one, theta 180. Now, we can consider this force is adding to this part. 2 plus 1.5 square, then 3.5 square. In downward direction, we can cancel out 2 squares, there is only 1 square. Then resultant is this one. Then we can consider this direction. Answer 2 is correct for the question number 31. But they have not given the correct direction in given table. We have to consider only rough direction. In 32, A, B, C, D, E are 5 coplanar forces of equal magnitude acting on a body as shown in the figure A. Which of the following diagrams best represent the direction of the resultant force of these forces? And we can consider given forces and we can cancel out A and E forces. A and E forces are opposite. Then we can cancel out. B is in this direction, C this direction, D this direction. And we can cancel out D and C. Now B is the correct diagram. The direction of B is representing we can cancel out A and E. D and C is in same direction. We can't cancel out D and C. Therefore, resultant should be like this. B is in this direction. We can add these two vectors in same direction. Therefore, we have to draw a straight line 2 times of this length. Then resultant is in this direction. We can get it as the fourth answer. Question number 32. Then 33, a uniform straight heavy plank of length 5L and mass 5M is kept horizontally on two supports separated by a distance 2L, as shown in the figure. A painter of mass M needed to work along the entire length of tank, carrying his bucket of paint. What is the maximum mass of the bucket of paint that can be carried by the painter without toppling the plank? Now I will consider there are two supports. This distance is given as 2L. This one is L. The total length of the tank is 5L, therefore this length also should be 2L. 5M mass of tank is acting on this plate, 2.5 length. Painter mass is capital L. We have to find the mass of bucket. I will consider it as capital L. Mass of painter is simple L. Mass of paint bucket could be obtained as capital L. Then we can consider at this place the reaction of this support should be 0 to toppling. If it is not toppling, we have to consider the limiting equilibrium. And there is a reaction at this place. We can consider torque around point X. We can write torque around point X. When getting point X, we can calculate without using capital R. Then I will consider torque around point X M plus capital M G into 2L. It is the clockwise torque. It should be equal to counterclockwise torque 5mg into this distance. We know that this distance is 3L and this part is 2.5L. It is midpoint. Then this one is 0.5L, half L. Then we can cancel out L term, G term, and we can simplify to find the value of capital M. 2M plus 2 capital M equals 2.5M. Then we can get 2 capital M equals 2.5M minus 2M, 0.5M. M value is 0.5M divided by 2. It means half M divided by 2. 1 over 4M. Then answer is 5 for the question number 33. Question number 34. Two teams starts to play tug of war using a rope of uniform strength on a hard flat horizontal surface as shown in the figure. Both teams apply equal forces as a result of the point O on the rope does not move. It means there is an equilibrium. Consider the following statements made by this situation. A. If each of the member of two groups apply the same force, the magnitude of tension throughout the rope is same. No, the maximum tension could be obtained at O. Therefore, A is incorrect. B. If the magnitude of tension on the rope exceeds the breaking tension, the rope will break only at point between P and Q. Yes, it is correct. The maximum tension is at the point between P and Q. It means midpoint of rope. C. The magnitude of maximum force that can be applied by an individual on the rope depends on the coefficient of static friction between feet of the individual and the surface. Yes, it is correct. The maximum force we can give the rope is depending on frictional force. Because of we have to consider the equilibrium of man, horizontal equilibrium. He is giving a pull. Therefore, force on man is in opposite direction, tension and friction. We can consider horizontal equilibrium. When considering horizontal equilibrium, tension is equal to the frictional force. Therefore, we can get that tension is depending on frictional force. Therefore, it is correct. Only B and C correct. Fourth answer is correct for the question number 34.